Too many alerts and not enough action? It's time to get SaltStack. SaltStack is an intelligent IT automation platform that detects security issues in critical business systems and then actually fixes them. With SaltStack, security and IT teams work together to define custom security policies with certified checks for CIS, DISA-STIGs, and more. You can scan systems for millions of compliance checks in minutes. Remediate compliance and vulnerability issues with powerful automation, all in a single platform. Visit securityweekly.com/SaltStack to learn more. SysDig is the first cloud-native visibility and security platform that eliminates the need for standalone tools like container security and monitoring. Using SysDig's unique data approach, enterprises can solve a variety of visibility and security issues at massive enterprise scale for multi- and hybrid cloud environments. SysDig will enable your organization to scan and block vulnerable images and enforce best practices pre-production, block threats, enforce compliance, and monitor application performance, proactively alert on incidents, reduce MTTR with forensics, and capture detailed audit records, all from a single unified platform. Accelerate your transition to containers and then have confidence in your ongoing operations using SysDig. To learn more, visit securityweekly.com/SysDig.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman. We need your help in a survey we are running for research purposes for an upcoming webcast. Please visit securityweekly.com/5 stages of automation maturity to submit your responses to our 5 stages of automation maturity survey. We will share the results in a webcast in November. This year's Compass Cybersecurity Symposium is being held at Twin River Casino in Lincoln, Rhode Island on September 25th. It's just 15 minutes outside of Providence. The venue has plenty of free and easy parking. Speakers include social engineering expert Chris Hadnagy and Security Weekly podcast founder Paul Asadorian. Use the discount code SW2019 to save $20 on registration. Matt, it's been 2 weeks, and there's, I think, quite a bit of interesting news for us to catch up on. Probably the most interesting and the most notable so far is a slew of exploit chains and related vulnerabilities that were reported by Google's Project Zero in the iPhones, throughout the iPhone stack. And what was interesting about it is there are obviously some interesting political aspects to the story because of who this was targeting. Apparently, this was found on websites pointing to a small minority population in China, the Uyghurs. And these were sites, however, that were blocked from internal access, apparently within China, but were available externally. So there's a lot of interesting things to look at here as we see, obviously, as we continue to see, I should say, the Android and iPhone ecosystems just to encompass, billions and billions of people. On an AppSec side, though, I did want to dive into one part of this by pointing to Azaria from Azaria Labs. We mentioned her in the past. A couple months ago, she had put together a free ARM emulator that was run by a browser. She's also taken some of the heap exploits here that were reported against iPhones and walking through some of the engineering aspects from it. So if you really want to dive into the technical aspects of these vulnerabilities, starting off with the very first one and from Azaria's websites in the show notes, it's a really cool technical dive. In addition to, and it's a good complement to the technical notes that are provided already from Ian Beer in the Project Zero website as well.
Yeah, what I thought was interesting in here is some web browser exploits, which I think we've seen aspects of this before. The one that was the couple that were interesting were some kernel vulns, right? Exploits at the kernel level, but 2 sandbox escapes, right? One of the things that makes iOS so unique over the Android is the ability to contain a potential attack and not allow it to spread laterally to the other areas through their sandboxing technology. But 2 of these exploits actually exploited the sandbox escape stuff. So I thought those were really, really interesting because we've seen the iOS devices be pretty secure compared to Android. And politically, right, this is Google's 0 day going after iOS, which Google has Android. So I thought that was another interesting slant to this research.
Yeah, it definitely it shows on the technical aspects, calling out like these chains do require the fact that it's one thing to get a Safari breakout, but then you need another exploit to get out of that Safari sandbox and yet another exploit into the kernel. And so it's really showing. And I think one of the cool things that Azaria was highlighting in her follow-up notes on this and her observations was that there's a lot of engineering that has to go into breaking out of these hardened devices because it's no longer one really simple buffer overflow that gives you the keys to the kingdom, so to speak.
Right.
And one of the other things that we'll see too is there's a lot of hardware that's actually tied to these security as well, both in the sense of trusted enclaves, but newer chips providing support for things like authenticated pointers. And that's what would make it even harder for exploit chains to buy. You're now going to need that sandbox escape, a kernel exploit, but you're also going to need some way to have an oracle into predicting, bypassing ASLR or getting into authenticated pointers on the more modern iPhone models. So it'll be really interesting to watch this as it develops over time, and of course, as part of that broader picture of Apple in particular just recently saying we're going to actually provide debuggable or debug-based models to researchers so that they can actually improve their relationship with the researcher community in order to make these sandboxing techniques that much more robust.
Yeah, and they upped their bug bounty, which we covered a few weeks back, for some of these additional exploits. I think what was it, the remote code execution on iOS was like $1 million bounty or something like that, right? So they're trying to also leverage that debug and these bug bounty programs to also secure all these different components in the iOS platform as well.
Absolutely. And now, speaking of someone who was, I believe, using iOS and tweeting from their phone, at Jack, his Twitter account started spewing a bunch of particularly vile racist things because he fell victim to a SIM swap. And this was interesting because here you have an account with two-factor authentication turned on. You have an application security program that's making sure the app is resistant to buffer overflows, to all types of other attacks, authorization bypasses, etc. And yet, when we can maybe pull this into the supply chain umbrella a little bit, but your SIM associated with your phone, if someone can social engineer your provider and basically swap that number into your own SIM, and then you can tweet directly via SMS, you've just bypassed all of that great security infrastructure.
Yeah, this is a really interesting attack. Obviously, created a bunch of buzz over the past couple of weeks since we haven't had a show. But it's a combination of SIM hijack and SMS, which is why Twitter's turned SMS off of their platform for now until they figure out a fix. But a very interesting attack vector here in what they did in order to make this work. Definitely some damage control at Twitter right now just because of all the issues associated with this one.
Right. And I think another reason I wanted to highlight it also speaks to the idea of, from a AppSec team, a product security team, when you're going through a threat model of this type of scenario, one of the things you could also consider is that here is an account with two-factor authentication turned on. But so for example, when you send a tweet from your app, that tweet can be signed. That signing can say, yes, here's an attestation that the user at one point completed their two-factor authentication and it's coming from this device. So it's signed, or here's an encrypted token or something that's proving that. With SMS, you don't have anything beyond those, few characters of the text message, and the identity just says, "Oh, here is the phone number it's coming from." So in a way, it's easy to say this was a predictable problem, but what I'm getting at is that just being able to send a tweet via SMS means you've also obviated all of these aspects of being able to sign who it's coming from, and you've fallen back from a strong identity assurance from two factors into a relatively weak identity saying just this particular phone number. So I think there's a good lesson there in the ways of trying to revisit and improve threat models when we're talking about what can account do when it has two-factor authentication turned off. Maybe there are some things that actually some functionality that in fact should be disabled.
Yeah, and I'm seeing more SMS style attacks. I got a text this weekend, somebody I don't know, saying, sorry, I'm busy, I can't talk right now. Well, I didn't click on
Yeah.
that. I just deleted it right away because I know
Yep.
there are people that are using SMS as an attack vector to redirect you to a site that then exploits a vulnerability on your phone. And so you're going to see more of this. Now, granted, I'm used to seeing this stuff, and I don't answer a phone call and I don't answer an SMS for people I don't know. I just ignore the call or delete the message, right? But not everybody does that. They'll see this weird message crafted this way, dig into the SMS text, which then may lead you down a link for something, and the next thing you know, you got exploits all over your phone. So just word to the wise out there. Just if you don't know who it's coming from, look out.
Look out. And I think an additional word to the wise out there, the word or a word to those who didn't realize, is that SMS can also be used. So there's two-factor SMS, getting your one-time code. There's also potentially SMS that's used directly for account recovery. So you may have a strong two-factor authentication turned on using a authenticator app, like the Google Authenticator or Authy or one of the others that's out there. But the account recovery flow, assuming, for example, that you don't have access to that authenticator app, may still fall onto a SIM, an SMS. And so you may have 2FA, but still be vulnerable to account takeover due to that recovery flow. So it's one of those things to call out there for both for consumers, go through and review what your different accounts look like, as well as for engineering teams in designing these particular workflows, making sure that these areas can be hardened as much as they can be to essentially what boiled down to social engineering attacks against the cell providers. Another really quick thing I wanted to revisit quickly. We talked about XSIM, a vulnerability in the past, and now there's just a RCE due to buffer overflow. Comes off of research that was related to Qualys research. Also, I think Tenable was involved for a bit as well. But I wanted to highlight because it shows the use of a null escape string, basically within a character string, so \0. And I thought that was pretty good because it's a little bit of a throwback to the nostalgic days of when hacking was simple and you actually didn't need to go through a sandbox escape through Safari into the kernel, et cetera, that modern iPhone exploitation that we're just talking about needs. But it also it's a great example of what are the expectations of what the data is you're handling, and the difference between at what point do you normalize data and then do your security check on it. So in this case, a \0 could be a null, which is a null terminated string, which back in the days of Perl, there were lots of really egregious vulnerabilities associated with null terminated strings in exactly this type of way. So we haven't seen this class of problems go away. We've just seen them become less prevalent, which is good, but we still have just seen them being talked about in broader terms now between normalization and when to do security checks and doing basically a different take on the idea of input validation. And I wanted to say that because that leads us into, I think, another article that you highlighted, 7 steps to web application security. So this was
I thought going to the fuzzing one was actually a little closer, right?
Yeah.
Because one of the things Fuzzing 101 does, right, is looks for potential invalid input, right? And we've talked fuzzing a lot. And I pulled the fuzzing article out because I think it's a good refresher for people who don't really know the basics around fuzzing and what fuzzing's there for.
That's a great point. And I added to it too. There's a professor from University of Utah who does great work in compilers and in security, mostly around the C and C++ languages. And he's written also about fuzzing as well. And he added a blog post, coincidentally, about a month ago, how to make your code more fuzzable. So what we're really talking about is an approach to code that says, Humans aren't really good at reviewing code. There's a lot of code out there. So how can we automate this? And how can we automate this from a security perspective? So the idea of fuzzing is there's sort of two broad approaches to it. One is sort of what we call it mutation, where you're just saying, here's the input that something expects. And this application may be a string, like in XM, and maybe it's strings associated with talking to servers or email, things like that. Or maybe it is a MPEG or an MP3. And it's because this is what people love to do, fuzzing codecs and fuzzing things like VLC. So what they'll do is they'll say, here is something that the application expects. Now just start randomly mutating it. See what happens. Does the application crash? Does it reject it nicely? Does it fail gracefully? Or does that crash actually lead to something that might be exploitable? There's also another approach called kind of like generative fuzzing, which basically says, we're going to take the components of this particular language, like JavaScript or C, and we're just going to start putting it together in lots of really unexpected and, to be honest, really dumb ways, but ways that are actually perfectly legit because we want to actually test the correctness of the program. And so that's what a lot of people have been doing, for example, when they're starting to fuzz browsers. What can JavaScript do? Because JavaScript is both a very powerful and a very messy particular language. And there's even one example I'd like to talk about is Jesse Ruderman, who was a Mozilla security researcher, security programmer. Way back in 2007, he gave a presentation at Black Hat called JS Fun Fuzz. And it was another example of using a fuzzer to find vulnerabilities, in this case, Mozilla. And you ran some code, basically unleash the fuzzer, let it run for 24, 48, 72 hours and going, and it's just going to find bugs for you. So it's a great way to approach security and basically instrument your code in a way that hopefully you can find crashes that are just part of quality control, but also find crashes that are part of security and security things that should be fixed.
Yeah, like null pointers or looking for memory leaks or passing URLs and all kinds of different things that can be tested for in a more automated way that would potentially reduce some of these vulnerabilities that we talk about today. The XM is a perfect example of that. Throw it the null character and what happens, right? You could have caught that a while ago, right? So the importance of fuzzing, I think, Mike, to your point, is it's this automated way for us to test non-expected criteria. When we build an app, we sit down, we say, these are the requirements. Okay, that's great, but that's not the data we're going to get necessarily when this app goes live. How do you test for all those out-of-band use cases? And fuzzing is a great way to test for a lot of that in a more automated way.
Absolutely. It's the idea that, people and our QA teams, for example, are great at putting together use cases. So here is a positive test case, here's a negative test case. They're not always so great at putting together what you could call abuse cases. And then if they are, they're maybe creating, a few dozen of them where a fuzzer can do a few thousand, if not tens of thousands of different cases and just figure out, here's a path that looks like maybe it is leading to a way that's going to be either more exploitable or just causing problems. And I wanted to add too, for example, you were calling out like null pointers and heap problems. Those are fantastic things that fuzzing can find. And even if you're writing in a language like a Python, for example, that doesn't, where you can't directly manipulate memory or directly manipulate pointers, it's still important to fuzz that language because you're still going to be parsing URLs, for example. You're still going to be parsing XML. You're still going to potentially parse strings with null escape characters in them. They're then passed on to a C-based API that is going to possibly now be confused by the length of a string that you gave it and where that null terminator showed up. So it's not like this is just about C or C++. It definitely can be applied to any of the numerous programming languages that you're developing in.
Mm-hmm. Yeah, so then now we lead back into the 7 steps to web app security. And the first one obviously is the user input, which again, fuzzing is a really good example of how do you test for some of that. Some of the other ones here though, Mike, I thought were pretty interesting. And number 2 that shows up is disable functionality you're not using, right? So think about this, right? You pull down the PHP library, and when you pull down that binary, think of all the things that are embedded in there. It's got curl and shadow and all kinds of stuff,
Yeah.
right? Are you actually using that stuff? Because if you're not, how do you disable it so the vulnerabilities that sit in those libraries can't be used against you for exploits later?
That's a great point, and that's where there's a couple things. I don't think I called them out in this episode, or in the show notes, but WordPress has had a couple problems, as you know, unsurprisingly so. But if you were disabling certain, like the PHP handler, protocol handler, um, unused functionality, if you don't need it, turn it off. You would have actually been protected against some of the recent exploit scenarios within PHP. So that's a great point to say. Just if you don't need it, turn it off. Another one that I really liked, well, I'll skip forward a little bit. Meaning there was one of the items was mainstream the AppSec team, and I think that ties right back into everything that Ty was talking about. Is basically saying, is your AppSec team just kind of sitting behind the desk waiting for the phone to ring and saying, "Oh, yep, time to go help you," or are they going out there and are they actually participating with the DevOps team? Are they participating in the development of code? Not necessarily writing code, although that could be one of the options, but at least understanding what's going on.
Yeah, and it's just not the security testing, which is in here, but it's actually getting security engaged with the development teams. It's great that security does its pen test every once in a while, but that's not mainstreaming security with the development teams to actually be a little more proactive than those periodic security tests.
Absolutely. I think that type of aspect of it talks about ongoing training as well. And I'm so happy that it used the word ongoing in there, because the worst type of training is a new hire employee training that says, cool, watch this, passively watch this very, very boring, even if it has, high production values, um, security awareness program. Now click on answer a couple questions, true false, about what's phishing, what's not phishing, and where to report this, and then you're done, and it has no other training happens. And this does tie in, when you do training on an ongoing basis, that's what starts to tie into the idea of a security champion program. In other words, it can be a little bit self-selecting. Ty did allude to, there's pros and cons of it, but if you can set up a model where you can say, here's some information we're going to make available to developers. Here's just, in other words, here's what SQL injection is. Here's what cross-site scripting is. And hopefully people can show up, start to think about that. Or even, here is what a SIM swap attack is. So pick on something that is topical in the news, talk about it, start to seed that security mentality within other developers. I think that is as good a training as any other. And honestly, I think if you make it interactive with people, it's a lot better than just that self-service kind of click through a PowerPoint presentation type of training.
Yeah, if you actually take a number of the recommendations in this article, you'll get that ongoing training, because if you're doing fuzzing to validate user input, maybe you're using aspects of that and other tools into your QA process, which it talks about that. If security is being mainstream with the dev teams, if you're doing a number of these things, that ongoing training is going to happen naturally, because you're going to be testing the application through the process. You're going to be identifying issues along the way. Security is going to be very visible with you. That is a learning process that's ongoing without this, well, let me go to my little site and go do my awareness training and get through it. I mean, this is real life, like everyday kind of happenings. That's better, way better on hands continuous training than most of those awareness programs.
Absolutely. And to kind of round things out, so we're talking about like working with developers, working with we're talking on the left side of the shift left mantra right now. There is also, once you do deploy an application, it does still require some care and feeding, or at least some attention. And that's where things like say, okay, maybe you do have some regular security assessment, whether it's DAS, SAS, pen testing. This also does explicitly call out as investing in a bug bounty program. And I'm curious what your reaction is to that, real quick.
Well, I'm not sure every organization can do that easily. And I don't know that every organization is ready for a bug bounty program.
Yeah.
Look, you've got some great big programs out there for some of the major vendors that are out there. I'm not sure every organization this is relevant. I'm not sure they're ready maturity wise. I mean, I could be wrong. I don't think every organization needs to invest in a bug bounty program.
Yeah, no, I think, these 7 steps, I don't think these were actually put in any particular order. But if we were to, start to jumble them around in an order of preference, recommendations, I definitely throw that bug bounty at the end, the very last thing you do, because bug bounty is a terrible way to start an AppSec program. It's also can be an inefficient and a pretty expensive way to find the vulnerabilities within your applications. Where it can be better for you and for teams is that you have some type of mechanisms where you're looking at code, where developers know about either dealing with user input or doing output encoding, or their code is dealing with the context of user generated data, things like that. You have a training program, you actually have a security team that is paying attention to this program, and to the developers, and helping them build out frameworks, adding frameworks to their code bases. And at that point, then you can start to say, cool, bug bounty program may start to make sense now, because that will be more of your continuous monitoring and will help you find those corner cases of things you may have forgotten.
Yeah, it's definitely an expensive way to start it. You do all these other steps first, do fuzzing, do periodic reviews, engage with the security team and make them part of the process, test security in your QA process. You're going to find a lot more bugs in those first 4 steps that'll make your application way more secure before you got to spend money on a bug bounty program.
Yeah, absolutely. And that's where let me pull this other article into this as part of that, because it's about securing the CI/CD pipeline and where the risks may be lurking within it.
Mhm.
Because if you haven't even started, let's not jump all the way to bug bounty without also making sure that we're looking at our CI/CD pipeline. And this comes to some of the classic aspects we talk about, like supply chain. As you said, if you're going out and downloading all this code and all these major, programming language frameworks, maybe you don't need all the functionality in there. Are you turning off any of it? Also, let alone where are you getting it from? Is this coming from? Is this coming from the the open source repos sources? Are these sources actually signed? Are you even checking those signatures for that matter? And are you doing some checking just to say there's no known vulnerabilities here? And then we get into just code aside, how are you handling the secrets so that
Mhm.
one service can talk to another, or this service can talk to the database? Because that's where, when we start talking about like cloud, AWS and its IAM model, it's nice and granular, but messing that up is the things that turns everything from here's our open S3 bucket or our Elasticsearch instance, or some more nuanced cases where here is one particular front end web server that might be popped, but then for some reason also has access to read all of these other resources that technically it really doesn't need access to.
Yeah, I mean, this is a conversation Paul and I have a lot in our day-to-day business because of the work we're doing with our software. We're
Mhm.
asking the questions around, where do we store secrets? Are we going to use AWS Secret Manager? Are we going to use something else? Because some of this stuff was embedded in scripts. It's not where it belongs, right? You got to pull all this stuff out. Where are you going to put it and keep it secure? Logs. Paul's been doing a lot on logging and making sure we have all the log data so that we can go back and troubleshoot not only performance but security of the application. These are things that are kind of outside of what developers think about when they're developing code. These are parts of the overall operational process. These are parts about
Right.
the tool chain itself and how things are getting into the different environments. How are you using the right credentials when you shift from test to staging to production? Right? I mean, all these things are just a lot of challenges that organizations struggle with, which can also create backdoors into your overall applications.
Absolutely. And that's why we have the ops side of DevOps, and why those either two different teams or those roles should be falling, those should be closely aligned, so that people can appreciate, oh, this is where my secret's going, and that's the implication, and what's the better way to do this? And one of the things to kind of maybe uh, add to a little bit, I did pull out just a relatively small article about Rails 6, saying that the new Rails 6 has a new filter or improved filtering capability for logging, as we were just talking about, and essentially for redacting logs. So that, yes, as you rightly pointed out, developers need logs to be able to debug what's going on. Obviously, software isn't perfect, let alone the security problems that come up, just bugs happen. And they need logs. Logs can be informative, but you also don't want to have those logs become now yet another source of risk, because you're accidentally, as we've seen in the news in the several times in the past, passwords going into logs, or PII data for that matter going into logs, or even credit card numbers going into logs. So seeing that these frameworks having robust ways to help with logging as well as to redact this type of information, I think is good. It seems to be kind of a slowly building process, but it's a good sign that I think these DevOps teams are talking amongst each other and saying, hey, we want to do the right thing. Please give us the tools to be able to do so.
Yeah. Just ask Paul the fun of parsing our custom logs. We did a segment on it on PSW a couple weeks ago. It's a learning process, and you're not going to get it perfect. But if you want to know how to construct logs better so your log analyzers can analyze them better, you should go to Paul's Security Weekly a couple weeks ago, pull that episode with the Gravwell guys, because we learned all the things you shouldn't do when it comes to building your own application logs.
That is, I find that the best way to learn. Make the mistake hopefully just once, and then do the right thing or do a better thing afterwards.
Yes, we hope so.
We hope so. Well, we also hope that everyone enjoyed our interview with Ty Sabano, as well as all the news we've gone through here. And I want to say thank you again, Matt, for a great conversation.
Always a pleasure.
So thanks everyone for joining us. We'll see you next week on Application Security Weekly.